Equivalent fractions. Equivalent fractions are fractions that are equal but have different numerators and denominators. When I'm looking at this problem I have on the board, I say that 1/2 is equal to 2/4 is equal to 3/6. We know that 1 is a different numerator than 2, and 2 is a different numerator than 3. And the same with the denominators. 2 is different than 4, and 4 is different to 6. So we're using pictures to show us why this is so. So in the first picture, we have 1/2. In this picture right here, we have 1/2 because one part is shaded and there are two equal pieces about the size of the green box. In the second picture, we have the same box. We have the half. We can see the black line under it. But the red dotted line in the middle indicates that the pieces are broken up into smaller pieces. So therefore, it leaves us with pieces about this size. So if we look at our whole shape, we have about 4 pieces that size, which represents the 4 here. The same amount is shaded as in the first picture. The only difference is the pieces are broken into smaller pieces. So because of that, I have 2 pieces that are the smaller red size, but I still have one green size piece that is still shaded in. And if I look further at 3/6, this picture has also been broken into smaller pieces. With 2 dotted red lines, we can see I have 3 red smaller pieces, but I still have one green piece. So I still have half of my shape that's shaded in. So that's an equivalent fraction. If I'm looking further, if sometimes you can't always break a shape up just by breaking it into smaller pieces, and you have to use 2 different pictures, which is the case with 3/6 and 5/10. So here I have one picture drawn and it's representing 3/6. And in the second picture here, I represent 5/10. But sometimes the orientation, that means the way the picture is turned, is different. So sometimes they might ask you to compare 3/6 to 5/10, how it looks here. So if you look at it, you can see that there are 5 pieces shaded, but still half of the piece, or half of the shape is shaded in. So I still have this one green piece that size. And even though it's on its side, I still have a green piece that is the same size in all 3 of those pictures. So that's why those are equivalent fractions. They're equal even though the pieces are smaller. Okay, now we're going to talk about fractions using a number. On this number line, you can see that I was trying to prove that 1/3 equals 2/6. So on the number line between 0 and 1, my job was to break the number line into 3 equal pieces. And so you can look at the red lines. You can see that there are 3 red lines that are approximately equal size. And because of that, we can name those parts thirds. So on the first red dot, we have 1/3, and you can see it here, 1/3. On the second red dot, we have 2/3 because we have 2 red lines out of all 3 lines. So that's 2/3. And then the last dot here, which we didn't make a red dot, but we could, is 3/3 because that represents all 3 lines out of them all. Then we had to break our number line up into 6. So that means I have 6 blue lines that are approximately equal size. And so when I look at that, I put a dot and I split them all up, and I can name them 6. So I have 1/6 on the first dot, 2/6 representing 2 blue parts of the number line out of all 6, 3/6, 4/6, 5/6, and 6/6. When you look at the green line going through the point of 1/3 and 2/6, they are both at the same point. They are both equidistant or equally the same distance from 0 and from 1. So therefore, they are equal fractions. Same with 2/3 and 4/6. They are both the same distance from 0 and 1. So therefore, they are equal fractions. So they're equivalent fractions. And now let's look at equivalent fractions using a set. So now you can see that I have 1/4 of 16 versus 2/8 of 16. If you look here, I have 4 groups to represent my denominator of 4. and then I'm going to put 16 into these 4 groups equally. So now you can see in one of the groups, when I look at one group, I can see there are 4 objects. So 1/4 of 16 is 4, or 4 over 1. And so 4 over 1 is the same as 4. It means that I have one thing. It's not split up. It's still in one whole piece. And I have 4 of them. And you can see the 4 groups here represented. 2/8 of 16 means that I have 8 groups, and I'm going to put the 16 into the 8 groups. So putting 1 mark in each group at a time, as if you're dealing out cards, you can see that I have 2 in each group. But the top numerator tells me that I need to look at 2 of the groups. So when I focus on 2 of the groups and count the total amount of objects, I can see that I have 4, just like in 1/4 of 16, or 4 over 1 if I wanted to put it as a fraction. So this is equivalent fractions using pictures, a number line, and sets.